Hi, my name is Bryan McWilliams. I'm a sales engineer with Sepio Systems, and I'm here today to talk to you about zero trust and zero trust hardware access. The part of zero trust often overlooked is the peripherals and the network devices and controlling them in a zero trust manner, the same way you do users and other technologies. So the first step to this, to being able to implement a zero trust hardware access policy, is visibility. We have to be able to see it in order to manage it. Sepio will go out and discover all of your peripheral endpoints attached to workstations, as well as your network devices, and then describe and identify them here in this asset visibility dashboard. So as an example, we see here there's a keyboard, it's a USB peripheral, who made it and what it is, how long it's been on the network, and really importantly, where is it? So this is the actual endpoint, the actual desktop machine that this keyboard is attached to. We do the same on the network side. You can see here with this laptop, what access point it's connected to, what Wi-Fi controller it's connected to, and then back to the switchboard. So two really important pieces of information. One, what is the device? And two, where is it? And then finally, we'll give you a risk score, a risk level on these devices. So in the case of this one here, it's obvious why this is a high risk of 100. It's the worst score because it's a known attack tool. And so often people struggle with where to begin. How should they prioritize the effort in terms of achieving this zero trust access, and especially of mitigating devices that they don't want on the network? Well, by sorting on the risk level and starting with the highest scores, the worst scores first, that gives you a strategy to go after the most important targets and work your way down into the lower risks, such as an unapproved peripheral that's not malicious, but that we haven't seen before. So that's the visibility component. And again, important that you understand that you have a risk with a device, as well as what that risk is. So if we move down from that overall dashboard into looking at our managed hosts. So these are hosts that HackOne is watching and managing. And I'm going to drill down into this one here. First thing to notice is really just the number of peripherals on this desktop PC, between what's built into it, what's plugged into it, and plugged into a hub. There's 31 different devices. And again, similar to before, we see what it is, we see who makes it, we see a description. And in this case, we've got an alert here. So notice that with the vendor ID and the product ID, this device is saying it's a Logitech keyboard. But with our technology, we're able to see its layer 1 characteristics, and we're the only platform that can do that. And we see that is that rubber ducky, that malicious device. And we will always see that, whereas your endpoint detection, your device endpoint protection is going to take its word for it, so to speak. It's going to believe it's a keyboard because it cannot see down to layer 1 to realize that it's spoofing something else. Notice too, that this device is not approved. So no rubber ducky is going to get onto this network once we set up and set them for not approved. There's a number of other actions that we can take on devices as shown in this menu. And again, notice how simple the interface is. It's really easy to work with. Now let's look at the network. On the network, we look at what is connected to the switches, to the network switches. And again, we will identify things that are not what they seem. And in this case, these are things that your NAC will miss, because your NAC is counting on identifying things by their MAC address. So notice here, we've got an alert on this port. The MAC address, it's a Dell MAC address, but you can see, because again, we see layer 1, the NAC doesn't. We see that this is a Raspberry Pi, and that Raspberry Pi is spoofing that Dell MAC address and telling the system that it's a Dell PC. The NAC believes it, doesn't have any choice, and we go to layer 1, we see it's not, we alert on that, and then you can take action to mitigate. Another case is a network tap. So this is a tap. Taps do not even have a MAC address. So the MAC address we see here is the MAC address of my desktop machine that's connected to that tap. Again, your NAC would not see this. It'd see this as a legitimate device. We see it by its physical layer characteristics, and we alert you on that. We also can help you with configuration and enforcement. So in this case, with this policy verification management, imagine that I want every cable TV camera to be put on VLAN 89. So whenever I see a device that's in this table of MAC prefixes, if I see anything that matches in that table, then I must appear this command, which by default will put that into the correct VLAN. If that command is not there, I'm going to alert on that, and I'll show you what that looks like in the UI. So here's an example where in this case, this is a must not appear. It's a forbidden policy. And so we're alerting on that. For this device with that MAC prefix, I do not want to see switch port mode access configured on the port. I'll alert you to that. I can also send that information to your SOAR or other tools, and they can take the automation and the action to configure the device appropriately. I hope this was helpful, and thank you for your time.